In our lesson today, we're going to have an introduction to rational numbers. This entire topic is going to involve rational numbers, which are going to be positive numbers, negative numbers, they're going to be whole values, fractions, decimals, and we're going to just get used to what rational numbers are today. Okay, there are many types of numbers that you're already familiar with as a 7th grader. The most basic types of numbers that you're familiar with are called whole numbers and integers. Okay, those are two different sets of numbers. We call them sets in mathematics, and they're grouped by characteristics. Okay, each set of numbers is shown below. First, we have the whole numbers. Whole numbers start at 0, and they go up by 1 unit at a time. 1, 2, 3, 4, 5, etc. Okay, and then we have the integers, and integers, notice, look a lot like the whole numbers. Notice, we see those 0, 1, 2, 3, 4, 5, etc. All of the whole numbers are also integers, but notice that the integers also include negative numbers. So moving to the left from 0, we have -1, -2, -3, -4, etc. So -10, -25, -1,000,000, those are all integers. Okay, notice in each set that they're whole values. There's no fractional or decimal part with it. Okay, so again, whole numbers start at 0 and go up by 1 unit at a time. Integers include those whole numbers as well as the negative whole values. In our first example, we're going to practice plotting integers on a number line. Each number has a home on the number line. You plot a number on the number line by drawing a dot on the line where the number is located. Okay, so looking at example number 1, we're going to plot each of the integers and we're going to label the integer with the corresponding letter. Notice our number line here. Okay, it's got arrows on both ends to indicate that the numbers go on forever in either direction. So after 10 would be 11, 12, etc. And then to the left of -10 would be -11, -12, -13, etc. And one thing to remember about the number line is that numbers get bigger as you move to the right. Okay, so the smaller numbers are to the left, the larger numbers are to the right. All positive numbers are bigger than negative numbers. Okay, and thinking about negative numbers, -1 is bigger than -5 because -5 is further to the left. -5 is bigger than -10 because -10 is further to the left. So the smaller the number, the further it is to the left on the number line. Let's plot each of these numbers. Again, we're going to put a dot on the number line where the number is located. So A is found at 8. So here's where 8 is on the number line. I'm just going to put a dot right on the line, and I'm going to label it point A. B is at -3, so we'll put a dot on -3 and label it B. C is found at 2. Here's where C is located. D is at 0. Put a dot on 0, label it point D. And finally, E is at -10. Put a dot on -10 and label it point E. Example 2 says, based on where you plotted each integer, give the distance between the following points. Okay, so in question A, they want the distance between points A and C. Okay, so here's where point A is at 8. C is right here at 2. Okay, I'm going to put my pencil point on one of the points. It doesn't matter which one, all right? So I'm going to put my pencil point right here on C, which is at 2. And I'm going to count up until I get to point A, all right? Don't start counting until you start moving, okay? So I'm right here at C. I haven't gone anywhere. Now I'm going to start counting because I'm going to start moving. 1, 2, 3, 4, 5, 6. All right, so the distance from point A to point C is 6 units. Try that with points B and E. All right, here's E at -10. Here's B at -3. I'm going to put my pencil point on E, and I'm going to count 1, 2, 3, 4, 5, 6, 7 units. Okay, finally for points A and E. All right, so E again is at -10. A is way up here at 8. So I'm going to put my pencil point on E. Don't start counting until you start moving. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 units apart. A and E are 18 units apart. In question 3, they say that there are many numbers that are not integers. I want you to write down 5 numbers below that would not be considered integers. Okay, so take a moment, review what integers were in the box at the top. Can you think of any 5 numbers that would not be considered integers? Okay, well, for me, I can think of a number like 1/2. That's not an integer. Or maybe it's a decimal, 0 and 25 hundredths. That's not an integer. Okay, or I can even make them negative, like -1/3. That wouldn't be considered an integer. Okay, maybe I've got a negative decimal. Maybe it's -4 and 1/10. Okay, that would not be considered an integer. Okay, there's another number, the number pi. Some of you might be familiar with pi. If we were to write that as a decimal, it would be 3 and 1/4, 1/5, 9, etc. That's going to go on forever. That's definitely not an integer. Okay, so what kind of numbers did we write down that are not integers? Well, we wrote down fractions, and we wrote down decimals. Okay, looking in the box at the top, remember integers, they can be positive, they can be negative, could be 0, but notice that they're always whole values. There are no fractions or decimals when we're working with integers. So we just learned that a fraction would not be considered an integer, okay? Fractions and decimals, certain decimals will fall under a different set of numbers. Fractions represent the ratio of 2 numbers. Because of this fact, fractions are called rational numbers, okay? And look at the root word of rational, it's ratio. Okay, fractions represent the ratio of 2 numbers. Okay, that means it represents a division problem. Now, decimals that terminate, which means that they stop, or repeat are also called rational numbers. So if it's a decimal that terminates, like I said before, maybe it's 4 and 1/10, that decimal stops, that's rational. Or maybe it's a repeating decimal, okay, like 0 and 3/10 repeated, like that. If I put a bar over the top of the number, that means it's a repeated decimal. Those would also be considered rational numbers. In the box, any number that can be written as the ratio of 2 integers is called a rational number. All rational numbers can be written as p over q or negative p over q, where p and q are whole numbers and q, the denominator of your fraction, cannot equal 0. Basically, if you can write the number as a fraction, it's going to be called a rational number. So we just said that any number that's rational can be written as a single fraction. And in example number 4, that's what we're going to do. We're going to write each number below in its rational form, which means as a single fraction. In letter A, we have a mixed number, 4 and 1/2. Okay, it's got a whole number part and a fractional part. We just want to write this, though, as a single fraction. And reviewing how we did this in earlier grades, remember, in order to change a mixed number into a fraction, you take the denominator, multiply it by the whole value, and then you add 1, and you put it over the original denominator. So my denominator is going to stay 2. Now we have to figure out for the numerator, well, 2 times 4 is 8. 8 plus 1 is 9. So 4 and 1/2 as a fraction is 9/2. In letter B, we have a decimal. Okay, we're going to rewrite this as a single fraction. And with decimals, it's very easy to do that if you know how to say the number correctly. This number, okay, a lot of people like to just say 0.3, but that's not the proper way to say it. Okay, this is called 3/10. The 3 is in the tenths place. Okay, you write the fraction the same way that you said it, 3/10. So this would just be simply 3 over 10. 3/10 as a decimal, 3/10 as a fraction. In letter C, this is 5 and 19/100ths. There are 2 decimal places, which is the hundredths place value. So again, I can write this as a fraction, 5 and 19/100ths. 5 and 19/100ths. Okay, but now this looks like how letter A looked. It's a mixed number. We want to write it as a single fraction. So again, we're going to keep the denominator of 100. To get the numerator, you do the denominator times the whole value, and then add the numerator. 100 times 5 is 500. 500 plus 19 is 519. 519/100ths. Letter D, well, that's just the whole value, 17. Okay, remember that you can make any whole number a fraction if you put it simply over 1. Remember that fraction represents a division problem. 17 divided by 1 is 17. So if it's a whole number, just put it over 1 and you have a fraction. In the next example, we're going to plot each rational number on the number line by, again, drawing a dot on the approximate location of the number. Label each rational number with its corresponding letter. So A is at -1 and 5/10. Okay, well, here's -1, all right. -1.5 is going to be halfway between -1 and -2. So I'm going to put a dot halfway in between those numbers, and I'm going to label it point A. That's where -1 and 5/10 is located. B is 4 and 7/10. 4 and 7/10 is located between 4 and 5, and because it's 7/10, it's going to be a little bit closer to the 5. So halfway, I'm going to go a little bit closer. Right here is point B at approximately 4 and 7/10. Letter C is 8/3, and to help me plot that on the number line, I'm going to convert that into a mixed number. Remember that a fraction represents division. 3 goes into 8 2 times. Okay, 3 times 2 is 6, so that means that there are still 2/3 left over. And you can double check that by doing this backwards. 3 times 2 is 6, 6 plus 2 is 8, so it's equal to each other. 2 and 2/3 is between 2 and 3, and it's again a little bit closer to the 3 because it's 2/3, so approximately right there is point C. And finally, point D, -18/5. Well, again, I'm going to convert this into a mixed number. I'm going to write my negative symbol, and now I'm just going to do the division, 18 divided by 5. 5 goes into 18 3 times. Okay, I'm going to keep that denominator of 5. And 5 times 3 is 15, which means that there are 3/5 left over. So -3 and 3/5 is between -3 and -4. And again, it's going to be a little bit closer to the -4, approximately right here is point D. In our last example, we're going to compare rational numbers. You can compare numbers by using the greater than symbol, which looks like that, the less than symbol, which looks like that, or the equal sign. Remember that numbers get bigger as you move to the right on the number line. So I've got this number line here. The smaller numbers are to the left, and they're going to get bigger as we move to the right. So let's compare each set of numbers using greater than, less than, or equal signs to make a true statement. In letter A, we have 3 and 3/100 compared to 2 and 97/100. 2 and 97/100, okay, would be approximately right about here, just before 3. 3 and 3/100 would be just after 3. Okay, so since 3 and 3/100 is further to the right, it's going to be bigger than 2 and 97/100. In letter B, we have -6 and 45/100, which would be somewhere even over here to the left of -5, compared to 32/100, which is in between 0 and 1. Okay, 32/100 would be right about here. Since -6 and 45/100 is further to the left, it's going to be less than 32/100. And that makes sense. All negative numbers are less than positive numbers. In letter C, we have 35ths, and then we also have 24/4. In order to compare two fractions, we should make them have common denominators. Fifths and fourths, the best common denominator would be a 20. So I'm going to change each of these into a fraction over 20. 5 times 4 is 20, so 30 times 4 is 120. 4 times 5 is 20, so 24 times 5 is also 120. Hey, these are equal to each other. Finally, we have -1 and 59/100 compared to -8 and 2/10. Well, -1 and 59/100 would be in between -1 and -2. -8 and 2/10 would be way over here somewhere to the left. So since this number, -1 and 59/100 is further to the right, it's going to be greater than -8 and 2/10. So just remember, the numbers get bigger as you move on the number line from left to right.